Hello everyone, this is part 2 of correlation and regression. In this session, we will discuss Karl Pearson's product movement correlation. In order to obtain intensity or magnitude of correlation coefficient, we are using Karl Pearson's product movement correlation. So this method is applicable for linear data. That is, whenever there exists a linear relationship between the variables, we will use this method. Say we have two variables x and y. Then correlation coefficient between these two variables is given by r. R we can also write it as rx comma y is given by covariance of x comma y by standard deviation of x into standard deviation of y. So the next question comes into our mind is what is covariance of x comma y, which is given by sigma xi yi by n minus x bar into y bar. I hope that you will be able to recollect what is xi, yi, x bar and y bar. Here xi, yi represents observations and x bar is arithmetic mean of the variable x and y bar is arithmetic mean of variable y. N indicates number of observations, right? And standard deviation of x is given by square root of sigma xi minus x bar whole square divided by n. We can also represent this as sigma xi square by n minus x bar whole square. Similarly, standard deviation of y is given by sigma yi minus y bar whole square divided by n, or we can also write it as sigma yi square by n minus y bar whole square. By substituting all these values, then the correlation coefficient is given by n sigma xi yi minus sigma xi into sigma yi divided by square root of n into n sigma xi square minus sigma xi whole square, and this part will be n sigma yi square minus sigma yi whole square. You might be thinking, what is the difference between sigma xi yi and sigma xi into sigma yi? There exists a difference, right? Here we will multiply x and y observations, then we are adding that product. Here first we will add all the x observations and all the y observations, then both of them are multiplied, right? And in the denominator, sigma xi square represents, we are calculating square for the each number and then the square of that numbers are added. Whereas here, first we will add all the numbers, then the resultant is squared. So that's the difference between these two terms, right? And Karl Pearson's is useful to find out correlation coefficient accurately. When you look at this formula, many of you might be thinking it's very big formula and how we can solve questions based on this, as it is going to take more time. But when we look at the previous papers, most of the times it will be based on properties or the values of covariance of x comma y and standard deviation of x and y will be given. Just you have to substitute the values in this formula to obtain correlation coefficient, which you can achieve in less than 1 minute, right? Now let us look into properties of Karl Pearson's. The first property says that correlation coefficient is unit free. No units for the correlation coefficient. The second point says that, say for the variables x and y, whenever there is a change of origin and change of scale, then the new variables are represented by u comma v. Then the correlation coefficient between the variables is given by rx comma y is equals to b into d divided by modulus of b into modulus of d into r of u comma v. That is the correlation coefficient of x comma y will be equals to correlation coefficient of u comma v if the sign of b and d are same. So you might be thinking what is b and d, which is not mentioned anywhere. So whenever there is a change of origin, the new variable u is represented by x minus a by b, and variable v is represented by y minus c by d. Here a and c are origin of variable x and y, and b and d are scale of the variable x and y. So from the given equation we can find out the b and d values, which are nothing but coefficient of x. So we can say that whenever there is a change of origin and a change of scale, new variables correlation coefficient will be same as variable x and y correlation coefficient if the sign of b and d are same. And the third property to remember is correlation coefficient value always lies between -1 and 1, including both the values. In the next session, we will discuss Spearman's and method of concurrent deviation. Please subscribe to our channel for latest updates. Thank you for listening and have a nice day.